Welcome to today's presentation, Build, Deploy, and Manage Applications with Habitat. Let's go ahead and get started. Dan, why don't you kick us off by telling our audience a bit more about yourself and what we'll be covering here today.
All right, thanks Jamie, and thanks everyone for joining us today to talk about Habitat. I'm sure a number of you are familiar with Habitat, but to a lot of you it may be new. There's been a lot of progress in the Habitat community recently, and in particular, we've seen some impressive outcomes addressing some of the big challenges that organizations face when they're modernizing their application portfolio. So today we're going to take you through some of those examples and give you a look at how Habitat works. Okay, so I'm Dan Hauenstein. I'm responsible for product marketing here at Chef, and I'm joined by Scott Ford. Some of you may know Scott. He's been instrumental working with our customers to tackle some of these tough problems they're facing, doing that with Habitat, getting maximum value out of it. So it's great to have him on to share what he's learned and show off how the product works as well. So the agenda today, we're going to start by sharing a preview of some upcoming research. We commissioned a report, the state of application delivery, and this is going to provide some good context and a baseline of comparison for you on several dimensions. Next, we'll go over the problem with applications. It's one problem with applications, but it's a big problem in how they're built and what that means for ongoing management and our ability to move faster. Then we'll introduce Habitat. We'll briefly cover the basics there. What is it? What are the major problems it solves? High level on how it works. And then Scott is going to show us how it works with a brief demo. He'll also share a couple of impressive stories from customers he's been working with in recent months. Then we'll wrap it up with the Q&A and get you on with your day. Okay, the survey. So as I mentioned, we recently conducted a survey in partnership with Dimensional Research to delve into application delivery a bit. The goal of this survey was to understand shifts in architectures, understand where people are focused as they navigate these shifts. Overall, we had about 350 application and operations professionals who took the survey, and we plan to release this survey in full in June. But today, we'll give you a little bit of a preview, share some of the data with you, give us some good context for what we want to talk about around Habitat. Now, one question we asked was, how do organizations measure successful application deployment? And it's pretty clear that speed is what people are after. 72% named that a key metric for application deployment success. We also had compliance audit success, change failure rate. These things rank highly as well, but well behind speed. It's also clear from the numbers that there's a long way to go. So we had 61% report that it takes them days or longer to complete the application build process, often much longer. And then 55% needed 4 builds or more to deploy anything to production. So speed equals success, but that's a real challenge for people. Meanwhile, there's quite a bit of optimism and some aggressive plans for containerization. So lower left, over half of respondents expect that they'll get 25% or more of their applications deployed on container platforms within the next 2 years. And to get there, just about 3/4 of people are undertaking some form of a lift, shift, and modernize effort to move those applications into the new architectures. Over half are also rewriting a portion of their application portfolio as well. So undoubtedly, there is a lot of effort going into this. Now, we live in a hybrid world. We'll live in a hybrid world for some time. Heterogeneity is the norm. It's increasingly the norm. And in the lower left, you have to squint a little bit to see the lines on this chart. But we asked what % of production apps run in each of these 4 environments: bare metal, VMs, containers, and serverless. So the horizontal axis represents the % of the portfolio, and then the vertical axis is the percent of respondents who answered for each of those. Now, you can see everyone has a mix of environments. There's a small percentage of respondents who have 100% VMs over on the right-hand side with that blue line, but everyone else has a mix. And if you look at this chart over time, as technology generations roll by, you'd expect each line to have a wave ripple out to the right and then back to the left, but they never go completely to the left. So we're always carrying along a significant percentage of older infrastructure technologies. So within that context, it's no surprise that management is the most challenging aspect of the application lifecycle. 44% of respondents indicated it so. So what does that mean? Ultimately, this tells us that in search of speed, organizations are moving to the next platform while carrying a lot of this legacy weight. This is already difficult to manage, but we can expect it's going to get harder. So now is the time to think about a comprehensive application strategy and do that in terms of how you build, deploy, and manage applications throughout their life cycle. Right, so if we want to avoid making the pain we've endured so far even worse, it's worth looking at how we got here. Ultimately, if we all agree that the valuable thing is the application, then we're building them wrong. Of course, it's with the best interest. The application's important, so let's be real careful about binding it to the elements that support it. But that means we have to spend a lot of time and effort getting the infrastructure right and then maintaining it over time. Just about every organization has applications running on operating systems from generations ago, Windows 2003 and the like. And it's not because people particularly love Windows 2003. It's because something important relies on it. So as these systems have piled up over time, and we saw in the data on the last 2 slides ago, I guess, that they do pile up, it's not just the effort of maintaining those systems. There are entire processes and support structures around all these applications. You have monitoring tools, you have CI/CD systems, release processes, all these things. So I'd say it's unsustainable, but really we have been sustaining it. It's just killing us. So one truth to accept and get comfortable with, and we've talked about this now a couple times, is that heterogeneity is the present and the future of IT. But instead of fighting against that complexity, can we abstract it away and focus on the application itself? So sometimes at Chef we talk about application-centric operations, and getting this right is foundational to what we mean by being application-centric. I particularly like this stat from the bottom of the slide here. Would it be valuable to have an application packaging solution that would allow you to deploy on any environment? Why, yes. Yes, it would. So that's good, because Habitat does that. And Habitat does quite a bit more, actually. It's designed to help application teams build, deploy, and manage any app in any environment. And there are 2 scenarios we see very frequently where Habitat's a big help. The first is for organizations who are trying to move their legacy apps to modern platforms. And because these applications are tightly coupled to infrastructure, you can end up needing to rewrite them entirely for these modern platforms. And of course, you don't always want to do this. So again, this is why we're carrying so much old infrastructure around with us. The second key thing we see is organizations needing to deliver on a cloud-native strategy. So many organizations have ambitious goals, even directives, to go all in on containers. They're adopting one or more platforms like Cloud Foundry or OpenShift, Mesos, other Kubernetes-based platforms. It turns out that's not very easy. So how can you accelerate that process and get more value faster? Now, the concept here overall is modeled on the way digital leaders run their businesses. The reason those organizations can adapt so quickly to new opportunities, move with such velocity, is they have a single way to deliver any application wherever they need it. This is a great approach. You should do it. Our goal is to help you get there. So that's really what Habitat is all about. Okay, so how does it work? the key concept here is to package the application independent of the platform or platforms on which it will run. So in the build process over on the left-hand side, you write a plan with your source code, all the packages and libraries your app needs to be built, all the packages and libraries your app needs to run. These are packaged up in an artifact, and because this is handled early in the process, you don't have to worry about these things later on. It also makes for much easier handoff from the team responsible for building the app to the team responsible for running the app. So you then export that package to run in any platform, and all applications are managed in the same way. So essentially, you're wrapping the application to create this uniform management interface, and then any app, whether it's legacy or modern, really can be treated the same from the outside. Now I'm going to talk just a bit more about the application-centric approach, what that means, why that matters. Just a few minutes ago, we talked about this approach of building applications from the system up, and that's what's illustrated on the left-hand side here. Now, when you do that, you end up with this entire heavy triangle to carry around with all its management challenges and surrounding process and tooling that we talked about. Now, Habitat's approach is to build from the application down. So you define the dependencies the application needs to be built and run, and then you package that with the application. Since it doesn't depend on anything else, you don't need all the weight on the left-hand side. The artifact is portable. You can move it to any infrastructure. Now, this also means you have complete control over every dependency deployed out into your infrastructure. When you've defined that up front, you know exactly what's gone into your containers, you know how to update your apps, how to find and remediate vulnerabilities, etc. Okay, so anyway, that's the high level. So let me get out of the way. I'll let Scott take you into how Habitat works and share with you some of his experience with our customers. Scott?
Thanks, Dan. Just give me just 1 second until this loads up. Okay, there we go. Okay, so what I'm going to be doing here for this demo is I'm going to take you through building, deploying, and managing a Java application with Habitat. Now, when you think about building any application, change starts on the developer's workstation. For Java developers, typically they work in an IDE like Eclipse. They build out artifacts such as jar files and WAR files and can test those locally. From there, change is checked into source control kickoff pipelines that produce that artifact and deliver it to an artifact store such as Nexus or Artifactory, or actually deliver directly onto systems. Now, the systems that those artifacts are delivered to are more often than not controlled by other teams, such as operations, whose responsibility is to ensure that all the dependencies and configuration are installed correctly on those systems. Now, this too actually goes back before that to the pipeline. You think about build and release teams. Their responsibility is to make sure that the pipeline, the worker nodes in the pipeline are also configured and with the correct dependencies and configuration to build out those artifacts. Now, if you've ever dealt with this, managing those dependencies and configuration is no small task, and with it comes a ton of risk. In the world of Habitat, we shift so much of that effort to the developer's laptop, where the risk is much lower. So building applications with Habitat, as Dan kind of went over this, we'll dive in a little bit deeper here. We start on the developer's laptop, like you do with other applications. We build out something that's called a plan file. And the plan is a shell script that's written in the target platform that you're going to be deploying to. So in the case of Linux systems, that's a shell script. In the case of Windows systems, that's a PowerShell script. The plan describes your application, all of its configuration, all of its lifecycle hooks, and builds out an immutable artifact. It's a heart file that can then be pushed up to a depot where that that artifact can then be deployed into various target environments, such as bare metal. It can be deployed onto VMs. It can be exported out into containers or run in Kubernetes, Pivotal Cloud Foundry, and so on. Once deployed, applications built with Habitat have something called a supervisor that manages that service, but can also bind together and form what are called service groups for running applications. These service groups can share together configuration so they can update themselves dynamically. Instead of orchestration, we think about that more as like choreography. The application itself is responsible for the configuration within the ring. The supervisor can also handle complex topologies such as leader-follower, where I can deploy out an instance and with a topology of leader, and it will wait until two other instances are there and you have quorum. And then the application itself will hold an election where it will elect a leader and handle any kind of failures. If a member drops out, then it can hold another election. So again, rather than relying on an outside solution for service discovery and topology, this is all baked in with Habitat as well. Now, another thing too that we'll be demonstrating too is that Habitat, when we deploy our applications out to the depot, every single artifact we build is tagged with a channel. Out of the box, we use stable and unstable, but any artifact can be deployed with arbitrary channel names to map to your software development lifecycle. Like if your applications typically move through environments such as development, QA, staging, production, artifacts can be tagged in that sense with those same names so that when you deploy them out, the supervisor managing your application can subscribe to that particular channel, and when a new artifact has been promoted to the given channel, the application can redeploy itself based on these update strategies, such as all at once or a rolling deployment, in where the supervisor will choose one instance of the application to update itself and then move on. If that's successful, move on to the other applications within the ring. So I'm going to be demonstrating all of this for you with our Java application. Now, the Java application we're deploying today is an application that is an interactive map of the national parks. The map right now is certainly doing its job, but I have a story in which we want to spruce up the map with more color to really make it pop. So switching over here now to my development environment, I have on my left my code editor, Visual Studio Code, and in pom.xml for Maven to be able to build out my artifact. Now, different from other repositories you might be used to, we also have a Habitat directory inside of the repo. Now, if I open this up, you can see a bunch of different files and folders in here, but the main one we want to dive into first is the plan. Now, we talked about every single application you build with Habitat starts with a plan. My target platform is going to be, I'm going to deploy this out to Linux infrastructure. So my plan is a plan.sh. And as we walk through this plan, the plan describes the application name, in this case, national parks, the description. On line number 3 here, we have what's called an origin. Every application you package up with Habitat comes from a specific origin. In my case, I have my own origin for applications I build, Scott Ford. But if you were building out your application for your organization, individual developers might have their own origin. But as an organization or an enterprise, you might have an enterprise-wide origin for all of the applications you build. Applications have a version number, maintainer, licensing as well. The really interesting stuff starts to happen on line 7 and 8 here. Now, with Habitat, we declare all of our build time dependencies and runtime dependencies. So in the case of artifacts, in the world of Habitat, Java and Tomcat are just dependencies. Now, I talked about my origin right here, Scott Ford. The maintainers of Habitat have a core origin in which we supply packages for lots of core libraries and applications that you can depend on for your application. So I'm depending on core Tomcat 8 and the core JRE 8. All of that is open source. You can always see how we build out those artifacts. And as we push those out, your applications you build can pull in those latest versions of these core dependencies. On line 8, though, we have our build time dependencies. So build time dependencies, if you think about this, I need to have the JDK in my build environment. I also am going to use Maven to package up my Java source code into a WAR file that can be deployed out on, with Habitat. So we're going to see this all in action here in a second. Now, my application that I'm building here requires a database to run. I'm explicitly stating here that when this application starts up, it's going to expect to bind to a database. And when that database, when it binds to that database is going to pass back a port in which it can, my application can connect to and get the data from the data store. Lines 13 through 15 here, we expose the port for Tomcat for the, so we can always, so other instances can bind to that. We have a load balancer. We get down here to lines 18 through 21. This is where we start to think about actually how do we build out this artifact. First of all, I want to prepare my build environment. I need to know where Java Home is. Java Home is going to come from the package path within core JDK 8. I also have a helper method here for building out my artifacts. I'm going to copy in my Java source code into the build environment. And once that's in there, I'm going to feed into that directory, and I'm going to run a Maven package. Moving down here to lines 30 through 33, we have the output of the build is going to produce a WAR file in which we are going to package up into the prefix. That's the root of the artifact that we're going to build. So that WAR file will now exist inside of the artifact where it can be deployed. So this is the plan file overview. We also have inside of the Habitat directory, we have what are called hooks. Hooks are the life cycle of your application. If you think about how you deploy our applications now, oftentimes we need to define how we initialize our application. We copy in the configurations to a specific directory. We prepare the environment. And once we do that, we also have to define how we're going to run the application. So we have a runtime hook for that. Now, these are just two of the examples that Habitat can do as well. There's also reconfigure hooks. If I make a change to my application, how do I reconfigure it? And also, Habitat can deal with health checking your application. So continuously, the supervisor, when deployed, will check your application and to make sure that it's healthy. Now, we also have a config directory, which is the configuration for Tomcat. Now, in here, we have what's called, we have a simple mustache templating for this particular, for my Tomcat configuration here. So config.server shutdown port. All of that is, we have a default configuration file called the default TOML, which we set the default values for anything that we want configured for Tomcat. So there's that shutdown port. By default, it's going to listen on 8805. But if at any point, if we needed to update that at the time we deploy, the supervisor can dynamically update our application and manage this throughout its lifecycle. Okay, so we've got our plan file here, and as I mentioned, I've already coded up a change now to my National Parks application that I want to be able to test out. So out here is we're running the latest version. The latest stable version is 6.3.2. I've coded up, my plan file is ready to go. The latest version is actually now going to be 6.4.0. So what I want to do is be able to, first of all, as a developer, I want to be able to test out as much as possible about my application on my local laptop before ever trying to go through a pipeline or deploy it out to any kind of environments. Now, installed on my laptop, I have the Habitat binary. Habitat version, you can see, is installed on my MacBook here. And Habitat has something that's called a studio, Hab Studio Enter. If I run this command, I'm inside of my National Parks directory. The studio you can think of is a clean room for building out applications with Habitat. What we want to do is ensure that any builds that I make are not influenced by any of the specific configuration that I have on my laptop. The clean room ensures that when I build it, I'm only going to be using whatever the key dependencies are that I've specified in my plan at the time that I build. Now, when you enter in the studio, what it does is it mounts up the directory that you started the studio in. So you can see over here, I've got my, my Java source directory, I've got my Habitat directory with my plan file, and from there, I can actually just run a build. And a build is going to read in the plan file, it's going to look at all those build time dependencies, any of the runtime dependencies that I specified, and it's going to go out to what we have. It's, I mentioned on a previous slide that there's something called the Habitat Depot, and it's going to connect to the depot, and it's going to pull down any of those runtime and build time dependencies and go through the process of building out this application. Let's see, for the sake of time right now, this build doesn't take all that long, but just I've already kicked off a build before starting this. You can see right here, this is it's starting to go through the process of resolving those dependencies. Something to point out here, if you see, I've declared Tomcat and JRE8 as my dependency, but if you look at what's being pulled down, Habitat has a complete understanding of not just those dependencies, but all of their transitive dependencies, right down to the version of glibc that's being used for the particular dependencies that I've called out here. So we're going to get complete visibility and auditability into the application to know every single version of every library that my application needs to run, and all of those will become a part of the final artifact that we build. So just for the sake of time, I'm going to go ahead and kill this. When we finish up a build with Habitat, we have a results directory within the studio. And you can see here that I've got some previous builds. I've got the previous production release that's running out there. But I've also got this version now of 6.4.0 inside the studio. Now, I actually am in a place now that I can run this. And if I run have sup status within the studio, you can see right now I have no services loaded. There's no packages running here. I talked about on that this application requires a database to run. Now, I've also already built out a package of MongoDB specifically for my National Parks application. I can query the Habitat Depot for versions of my MongoDB package as well, have pkg search .forward/np-MongoDB. And when I get back, I see that there's a number of versions up there. If I just run one of those, if I run a version of this right now into the studio, it's going to pull down the latest stable version, what's running in production. So I can do that with have SVC load .forward/np-MongoDB. Now that's going to pull that down. Again, it's pulling down not just MongoDB, but all of the transitive dependencies for that specific version of MongoDB, so I can be sure that what I'm running is the latest stable version that's in production. Now if I run have SVC status, you can see that I've got MongoDB, and it's started up in a service group of default. So it's the np-mongodb.default service group. Sup-log will show me that MongoDB deployed successfully, it's imported the data, and it's ready to go. Now what I'm going to do is I'm going to start up my National Parks build that I just created, and I'm going to bind that to the database. So we're going to say have SVC load results.forward 6.4, and let's grab 0.58. And we'll say -- bind to the database, and np-mongodb.default. When we do that, that's going to load up this latest artifact within my studio. And again, seeing all those dependencies, transitive dependencies that my application needs to run. Just 1 second here. Okay, there we go. And sup-log one more time will show me that Tomcat is starting up and it's now deploying that WAR file, my National Parks WAR file, out into Tomcat. If I switch back over here to my browser and go to localhost National Parks, we can see now here's the latest version of National Parks. I'll wait for this to load up on the screen. See, it's taking just a second. So we've got the latest version. We've got all the color we were hoping to see with our application. The latest icons are up there. So it looks like it's loading for me. I don't know if everybody can see that quite yet. Dan, can you see that yet?
I can't.
Yeah, it looks like,
okay.
Looks like it's reloading now. Just 1 second here. It's still spinning for me. So give me just 1 second here.
I think actually it is coming through for people that maybe our audience view, Scott. So if it's running on your computer, you may be okay.
Okay, great. All right, so we've got the latest build of National Parks out here. I'm able to test this out, and it's looking good to me. So I'm ready to go ahead and deploy this out to another environment. Now, what I've done in this case is I've used HashiCorp's Terraform to deploy my application into both AWS and into Microsoft Azure running on just VMs. So what I can do here is I'm going to go ahead and SSH into my AWS instance, and I'm going to tail the output of the supervisor. And on the Microsoft Azure as well, I'm going to SSH into that box and tail the supervisor. Now, as I described before, every single application, when I deployed this out, I deployed my application to listen to the Habitat Depot's stable channel. So I can now push this new artifact that I've created here on my local laptop up to the depot. So I'm going to go ahead and say have pkg upload results Scott Ford 6.4.5 is that version. We're going to go ahead and upload that up to the Habitat Depot. And once deployed up, we will go ahead and I'm going to, actually I've got it right over here. I'm logged into what's called Builder. And Builder is a continuous delivery platform for applications built with Habitat. So I have my origin up here. I have my National Parks application. You can see the latest version that was just pushed up is that version that I tested here on my local laptop. But right now, that application is only a part of the unstable channel. So that is not affecting my production in any way. Again, I can tag this artifact with multiple channels if I wanted to tag it with dev, test, staging, production, and so on. I could do that and promote it through various environments. In this case, I'm just going to use the one that's out of the box. Over here on my right, I see that latest version is 6.3.2. Scrolling down here inside of Builder, you can see that here's my plan file. You can see what's configurable about this particular application. And then further down, here are those declarative dependencies for my application, as well as all the transitive dependencies. So I can know exactly what's out there. This is completely auditable. Any kind of zero-day vulnerabilities come up with core libraries such as glibc or OpenSSL if you depended on it. you would know about those things, and those can trigger rebuilds of your application, which you can then promote out. So some really exciting stuff there. Now, what I'm going to do is I'm going to go ahead and I'm going to promote my artifact to stable. And then when I do that, we'll switch back over and we'll look that my applications running in two completely separate clouds are going to recognize that this promotion has happened, and Habitat is going to redeploy my application to the latest stable version. So are you sure you want to promote it? Yes, I'm going to go ahead and promote it. Switching back over here, we can, as we're to my environment, what we'll see should just take a couple of minutes here. We'll see that the supervisor will recognize that artifact has been promoted, and then it will do the proper thing to redeploy our application. So just 1 second here. Okay, so there we go. We can see on the top right now in Azure, I think that one just went ahead and, okay, there should be soon. Step 3.2 is still deployed out. Okay, so there we go. You can see now in Azure on the top, we can see that Habitat has recognized that this new artifact has been promoted. It's redeployed my application and is now on the latest version. So if I refresh Azure, that is now on the latest version. And then down below, we should see here in just a second that AWS, I'm sorry, it was AWS that did that first. Now Azure's redeploying itself and it's on the latest version. So if I refresh that over here, both of my applications have been redeployed onto the latest version. So some really exciting stuff. All this stuff, all the capabilities you're seeing here are part of Habitat. So how do I build it? Once deployed out, how do I manage its lifecycle? How do I promote that through its various environments? You think about the build system, the builds that happen, that's all too part of the process of packaging up your application with Habitat. Now, as I switch back over here to my environment, another really exciting thing that Habitat can do that we talked about before is it has the ability to export the artifacts we build to other target platforms, such as Docker, Kubernetes, Pivotal Cloud Foundry, Mesosphere, and more. So what I can do in my studio is I can run a habpkg export Docker results. It's got 4, 5. We'll go ahead and export that out. And so it's going to go through the process now of exporting my National Parks application as a Docker container and make that available for me on my local system so that I can test that out as a container. From there, I can push that up to other container registries, whether that be Azure Container Registry, Amazon Container Registry, Docker Hub, and then deploy that out to various container runtime environments. So it should be just a second here to get that thing deployed out. And in the sake of time, I'll go ahead and kill this because I've already built this out before. We're going to go ahead and exit out of the studio. And once exited out, if I run a Docker PS, you should see I've got nothing running on my system right now. But if I run a Docker images, we can see that I've got my National Parks version 6.4.0 is been published to my local Docker images. And I've created a simple Docker Compose file within my repo here that defines how to bring up this application locally and so I can test it all out. So I'm going to just go ahead and run a Docker Compose up. Waiting for the binds to happen. There we go. It's preparing, it's deploying itself out. And I did just one simple thing here on this application. I went ahead and had this listen on port 8081 instead of 8080. And sure enough, there's my application running as a Docker container, as Docker containers, the same thing. So Thinking about that, stepping back, we have now a story that gives you a consistent way to build out any application and then decide at deploy time, where do I need to deploy this? Do I need to deploy this to bare metal? Do I need to deploy this to VMs? Do I need to export this to a Docker container, to Kubernetes, to Pivotal Cloud Foundry? A consistent way that that's done, and then once deployed, a consistent way to manage that application's lifecycle. All right, so I'm going to go ahead and stop sharing my screen right now and talk a little bit about some of the other ways that we've been using Habitat out in the field. So, you know, Habitat's been around now for you know, about 1.5 years, 2 years, and it's really starting to pick up steam out there. The community is growing a lot, but I've been very fortunate to be a part of some really exciting new projects with some enterprise customers. One of the more recent projects I've been focused on is helping a large auto manufacturer migrate their applications into their brand new state-of-the-art data center. Now, this enterprise was making good headway with migrating modern applications to platforms such as Cloud Foundry and Kubernetes within the data center, but they were struggling with a comprehensive solution for literally thousands of consumer off-the-shelf applications that were critical for business units. Now, these applications, like, there really wasn't an option to rewrite them. And not only that, but they're doing their purpose. So they weren't even thinking about rewriting. They needed a solution for how to get those applications into the data center. Now, it would be really easy for us to take a brand new modern application and just and package it up with Habitat, but then you might get the question, well, sure, you can do that with the modern. What about something really hard? So what we did to prove out the value of Habitat, we asked this enterprise to give us one of their most difficult applications, a high-profile application that they were looking to migrate. Now, that app turned out to be a Windows application from 2003, written in Delphi in Portuguese. We don't have anybody at Chef that speaks Portuguese, at least none that I know of, none of the engineers on the Habitat team. But enter Matt Rock, who is our Habitat engineering lead for Windows, and in pretty short order, he was able to package up that application with Habitat, and we were able to deploy that into the cloud. Now, into the cloud means just running on a VM, but not just any VM. What Dan talked about earlier today about carrying around these legacy platforms, Windows 2003, Windows 2008 R2, the application that was running, this application that ran on Windows 2003, we were able to package it up with Habitat, and once packaged up, we were able to deploy that out onto a Windows 2016 VM to make sure now that it's running on the latest supported platform for this customer. So I don't know, I've been at Chef now for about 4 years, and I had an incredible opportunity to travel around the world and visit all kinds of enterprises. And for me, I'm so excited to go out and tell companies that you don't have to scrap your legacy applications to migrate them to the cloud. Legacy applications can be built, deployed, and managed just as successfully as modern applications. Another really cool story that I worked on at the tail end of last year was helping a large agribusiness package up their applications to run in OpenShift. Now, obviously, there's lots of success stories out there of enterprises deploying their applications as Docker containers, deploying them out to platforms such as OpenShift and Kubernetes. In this case, the company had separate processes for how they built out the Java artifacts and then took those Java artifacts, packaged them up as Docker containers, deployed them into environments, and tested them out. Using Habitat, we were able to shift so much of that to the left so that developers had a way to test their application, the full stack of their applications on their local laptops using Habitat in the Habitat Studio. With that, with the benefits of how Habitat gives you the tight control over the build time and runtime dependencies, this organization was also able to have a full audit trail of their application dependencies right down to the version of glibc that was being deployed. And one of the great moments for me during this project was when the customer realized that that initial artifact we built, that heart file produced, could run the same on a VM or bare metal as it could in OpenShift. So it's really that aha moment of we can take any application, we can package that up, and then decide where to deploy that out. So really, really exciting stuff. I feel that we're at the tip of this movement right now. We've got a bunch of new projects that we're working on, and hopefully a lot more stories for the community soon. So with that, I'm going to pass it back over to Dan.
Excellent. Thanks, Scott. You know, what really strikes me in those stories is these are practical issues. These are things that everyone is running into, seeing those problems or something similar. So it's really cool to see those being solved here in the real world. Okay, so let's wrap it up. The world is heterogeneous, it's hybrid, it's getting more so every day. That's making it really difficult for all of us to manage applications for speed. But there's a path to easing this challenge, and that is developing a single way to deliver all your applications. And that's the secret to the velocity of organizations that are digital leaders. And that's what Habitat helps you do. It gives application teams a consistent way to build, deploy, and manage any application from legacy to modern. And Scott showed you how that's done. So, all right, so let's move into some questions. And I'm really happy to say that to help answer some of those questions and questions, you may have seen some of those starting to be answered in the Q&A panel. We have two of the absolute experts on Habitat joining us here from the engineering team. We've got Chris Nunciato, we have Salim Alam, and they're here available to answer some of these questions. Okay, so let me get into it. And actually, this first one is, what are the most consistent use cases adopted by end users and customers for Habitat? And I guess I can start there and say, you know, we really outlined these two throughout the webinar. One is trying to get your legacy applications, you know, lift, shift, modernize those legacy apps into modern platforms. And then the second one is delivering on this cloud native strategy. How do you accelerate your path to container architectures? And those were the two examples that that Scott shared as well. So I don't know if Scott has anything to add on that one, but I think, you know, that's what we see consistently across the environment that we work in.
Yeah, I think that sums it up quite well, Dan. Yeah.
Okay, and then we had one that, Salim, you answered this, but maybe just let everybody know, is the latest JDK version supported for builds?
Yeah, that's actually a great question because it goes to some of what we call core packages, which is a fairly large set of packages that are available on the builder site that Scott, you had shown. And I put the URL in the answer, but you know, anybody who's interested in a specific version of JDK or, you know, whatever they're looking for as a dependency, that site is searchable. There's a lot of information there. So I encourage people to go check that out.
All right, excellent. Let me grab another one here. How about this one? I think, Scott, you're looking at this one as well, but how would Hab Studio test an app dependent on an AWS resource, such as DynamoDB?
Yeah, this is a really, really great question and a really cool one as well. We're starting to see inside the Habitat's got a really vibrant community, and we're starting to see a lot of people take Habitat into directions that we really never envisioned as well. So it's really flexible and powerful. But one of those, this particular question that is asking about how would you use a resource such as DynamoDB or something like Oracle that's already built out at an enterprise. We did this exact use case for the agribusiness that I spoke about. So what we did in that case is we built a really small Habitat package whose only job it was to provide configuration. And so if you recall in my demo, what I did was I brought up an application and I bind that to the database. My database was built with Habitat. So that's simple, right? The supervisor's managing MongoDB, they pass information. In the case of something like Oracle that may be deployed out on-prem, or DynamoDB that's being managed by, that's a managed service, what you do is you build out this small artifact, and all it is the pointers. It's the configuration. What's the endpoint that I'm connecting to? What are the credentials that I'm using to connect to that endpoint? And so at deploy time, though, Habitat has the ability to dynamically update those configurations. So say in my development environment, I have one DynamoDB that I'm pointed to, but in production, it's another one. All of that could be injected into the configuration of this small package, and our application will do the correct thing. Now, there's other things that we haven't really gotten into in this demo around encrypting traffic with the Habitat supervisor, which is supported, as well as secrets management, which is supported. That's more of an advanced topic, but we would love to have you jump into the Habitat community, and we can dive through that. We have a lot of great documentation up on habitat.sh as well.
All right, awesome. Thanks, Scott. There's another one, Salim, that you had answered on. Well, I'll just read it out here. All other things being equal, should greenfield projects aim to use pure TOML for application configuration? It seems to me you get maximum leverage from hab config apply that way.
Yeah, this is another great question and observation, because one of the things that Habitat really makes very easy and actually very pleasurable in terms of managing applications is being able to curate those different configurations from different applications into a very consistent model, so that when you're applying these configurations, you can just do that with the exact same way, regardless of which type of application that you have, whether it's a legacy application or a greenfield application. We don't have any specific mandate to use TOML or not use TOML, but again, having that consistency of workflow is one of the big things that Habitat brings to the table.
Hey, Dan. There's a couple of great questions in here that I want to go ahead and jump into. So one question right here is, can I have a private builder on-prem? And we're really excited to say, yes, you can. That's something that we are helping our customers deploy out. It is something that we can work with you on. So if you would like to have a private builder, we can do that. Another thing that we have here, another question that's is, how does Habitat work with Vault? The other customer story that I talked about the large auto manufacturer, we did exactly that. We deployed out HashiCorp's Vault with Habitat, and applications that you build with Habitat can then leverage Vault for secrets management. I am going to go ahead for the person that asked that question, I'm going to go ahead and share the link to the repository to core plans. But if all of the core plans, as we mentioned, for Habitat are open source, there is a core plan for Vault, and you can leverage that today.
All right, great. We had a question here. Can I create my own core package in Builder?
Yeah, I can take that one also. That's another great question. So for the core packages, we have, we're not just the Chef team, Habitat team that's maintaining them, but we have a very large community that is also empowered to create new packages and become a core package maintainer. There's more information on if you go to the habitat.sh site, join the Slack channel and become part of the community. Absolutely, anybody can come in and create a core package once they become a maintainer.
Excellent. There's another good question here around, it seems Chef and Habitat overlap with some configuration management. So how do you normally see these two products work with or incorporate each other?
I can go ahead and take that one as well, Dan. So Chef is still completely relevant, but what Chef's core capabilities are around infrastructure configuration. So when you think about that, like I'm bringing up a VM or some bare metal, what are the core things that need to be configured on those systems? Well, they need to be tuned, right? Performance tuned. They need to be hardened. They might need to have things like Active Directory or LDAP configured on them. But beyond that, once you set up the systems driven from code, then you can, all you really need on them is the Habitat supervisor running, and you can then drop applications on top of that to be managed by the supervisor.
All right, excellent. There's another question probably for you as well, Scott. Is the code for this demo publicly available?
It absolutely is. For the person that answered that, I can share that. Now, Jamie, if I click send to all, I don't know if other people are interested in this, but we can make, the code is absolutely available for public consumption. And so I'm going to share that with the person that asked, but if there's a way to follow up with this for everybody, I'm happy to do that.
Yeah, you can go ahead and share that, send all to everyone on the call can see that, and we'll follow up with that in an email as well.
Great. So that's been sent out to all. Anybody that's interested in trying to spin up the demo that I brought, there's a GitHub repo up there. Go ahead and fork it, and you'll see my communication information up there as well if you want to chat with me about it.
All right, great. One thing I do want to point out there, where there are questions around product direction or things that may be coming, I want to point out that ChefConf, and hopefully we'll see a number of you there, but ChefConf is next week. So we'll have announcements at ChefConf as we always do. And I just encourage people to keep an eye on those things to get kind of the latest and greatest around what we've got available on this front.
Okay, thank you for the presentation, and Chris and Celine for helping us answer questions. We are almost out of time here. For those of you that submitted questions that we didn't have time to answer, we'll follow up with you via email to address those in the next week or so on the Chef blog, where we'll recap everything we covered here today. As a reminder, a copy of today's slide deck and additional help materials are available in the resource list widget at the bottom of your screen. We encourage you to download the slide deck and bookmark any links that you may find useful. We, of course, hope you found value in the information that Dan and Scott presented today. If you like what you saw, we encourage you to share the recorded presentation with your teammates or professional networks. The on-demand version should be available by tomorrow, and we'll email you as soon as it's ready. Thanks again for your time, and have a wonderful day.